This section is on classification of triangles and interior and exterior angles, as well as the angle sum theorem. So I'll go over this in a little more detail in a moment, but we can classify triangles according to angles or sides. According to angles, you can have an acute triangle, a right triangle, an obtuse triangle, and sometimes we talk about equiangular triangles, but usually acute, right, and obtuse. According to sides, we've got our isosceles, equilateral, and scalene. We'll also discuss the exterior angle theorem, what remote interior angles are, as well as exterior angles, and the angle sum theorem. So first of all, let's talk about exterior angles as opposed to interior angles. Okay, let's focus on the picture here. Here's your triangle. Interior angles are the angles on the inside. So these three. Exterior angles are when you extend the sides, the angles you get to the outside. So if I extend this side, this is an exterior angle here, whereas this one is an interior, and as you can see, these are going to be supplementary. And we can do the same thing over here. We extend that side. This angle here is an exterior, this is an interior, and those are also going to be supplementary. All right, we have what's called the a theorem for remote interior angles. Now, in this particular triangle here, angle 4 is an exterior angle. 1, 2, and 3 are all interior. However, angles 1 and 2 are called remote interior because they're far away from angle 4. So these are next to each other. These two are far away from 4, so they're called the remote interior angles. And it turns out that if you add the two remote interiors, you always get the exterior over here, and that is because we first of all have the triangle angle sum theorem, which says that all three angles in a triangle add to 180. So angle 1, 2, and 3 add to 180. So we know that. 1 plus 2 plus 3 is 180. We also know that these two angles are supplementary. So angle 3 and angle 4 are 180. Well, if these two are 180 and these three are 180, we set them equal to each other. So we have that angle 1, angle 2, and angle 3, you add them, you get angle 3 and angle 4. And I simply cancel out angles 3 on both sides. So I cancel that out, and I'm left with angle 1 plus angle 2 is equal to angle 4. And so this is occasionally useful, this idea that the remote interiors, the sum of them is equal to the exterior. Oftentimes we don't end up using it, but sometimes it can be useful. Okay, let's go back to classifications of triangles in more detail now. All right. First of all, classifying according to the lengths of their sides. A scalene triangle has no equal sides, so 1/2/3/. So no equal sides on a scalene triangle. An equilateral triangle, however, has all three sides are the same. So 1/1/1/1/. And what we'll see is that for an equilateral triangle, besides all three sides being the same, all three angles are the same as well. And since all three angles must be the same, and they have to add to 180, we know each one must be 60. An isosceles triangle is a triangle that has at least two sides equal. Usually just two, but theoretically an equilateral is also isosceles because three sides is the same as at least two. So at least two sides, and in this case these two sides are the same. Angle A is called the vertex angle, angles B and C are called the base angles, and these two angles will be congruent. So isosceles triangle, two sides the same, and the opposite two angles the same, at least those two sides. Okay, going down to this classification, this is isosceles because these are the same. This is scalene because they're all different. This is equilateral because they're all the same. Now classifying according to the angles. An acute triangle, all angles are less than 90. All three are less than 90. An obtuse triangle, one angle is greater than 90. You can't have more than one angle greater than 90 because you've only got 180 degrees total in any triangle. So we have one angle bigger than 90 for obtuse. For acute, all three have to be less than 90. And finally, a right triangle, we have one angle which is 90 degrees, and in that case, the two sides next to that angle are called the legs, and the side opposite, the longest side, is called the hypotenuse. That's opposite the right angle. Again, a right angle triangle has one 90-degree angle. So here we have an acute triangle. They're all less than 90. Here's obtuse. We've got one bigger than 90. Here's a right triangle, and there's their symbol for right triangle, is the little box there. Okay, a little bit more about isosceles triangles. Here again are our two, they're called the legs for an isosceles triangle, just like we have legs for a right triangle. They mean something different for isosceles triangles, but we still call them legs. So here are the legs at the same length. Our vertex angle then is over here. These are our two base angles, which will be congruent to each other, and this is called the base. It's opposite the vertex angle. Okay, can these triangles exist? Can you have a right isosceles triangle? And the answer is yes. Here's a right angle. These are the same length. Therefore, these would be the same angle. And because you have to add to 180, if this is 90, these two must each be 45 degrees. And this is a triangle we'll use a lot when we get into trigonometry eventually. So that's question number 1. That's a right isosceles triangle. Question number 2, a right equilateral triangle. Well, for a right equilateral triangle, right means you have to have a 90-degree angle. Equilateral is going to mean they're all going to end up being 60. So you can't have 90 and 60 at the same time. So number 2 is no, that cannot exist. A right scaling triangle, well, that works okay. For a right scaling triangle, here we have a right angle and 3 different lengths, and maybe a 3, 4, 5 triangle would be a quick example of a right scaling triangle. An acute scaling, no problem with that either. Maybe a 3, 4, and 6 would be acute scaling. An acute isosceles triangle, that's not a problem either. Same length, different length, they're all less than 90. Obtuse scaling, we just make the vertex angle bigger. The vertex angle has to be the obtuse one, though. You can't have the base angles be obtuse, because otherwise you'd have more than 180 degrees, because you need 2 obtuse angles. Obtuse equilateral, that can't work, because equilateral is going to be 60 degrees, and obtuse is going to be more than 90. And acute equilateral, that's every equilateral triangle is always acute, because they're always 60-degree angles, and those are less than 90. Okay, some practice problems with these concepts. Okay, this is an exterior angle. These are the remote interiors. So you simply add them and you get 125 degrees. Now, another way to do it is to do 180 minus 60 minus 65, and you would get this is 55 degrees. And then you know these are supplementary, so you do 180 minus 55, and again you'd get 125 degrees. So either way, you can either add the two and you get this answer, or you realize these add to 180, these add to 180. Over here, these are the remote interior angles for M, so 36 and 93 is 129 degrees. Okay, looking at the triangle on the left here, we got 55 and 90, which is 145. Subtract that from 180, and this angle then is going to be 35 degrees. And now if that's 35, we can say that this angle here is supplementary to it, so that's going to be 145. So now we look at the triangle in here, and we know it's got to add to 180, so 10 plus 145 is 155. Subtract 155 from 180, and you get 25 degrees for Z. Okay, over here, we know there's 180 degrees in a triangle, so if we add these two up, we're going to get 158. If we subtract that from 180, then this angle here is 22 degrees. That means this angle here is 22 because they're vertical. So angle 4 is 22 also. So then we do 70 plus 22 and we get 92, and we subtract that from 180 and we get angle 5, which would be 88 degrees. Okay, finally 16 and 17. If the sides are 10, 8, and 10, two of them are the same. So this is going to be an isosceles triangle. And here we have one obtuse angle, so that's going to be an obtuse triangle.